They had astronauts speaking about their experiences in space. So I got to meet Sally Ride. So this is one of the things I always kind of talk about. I think my mum has a video that she plays that I kind of talked about some tips for young engineers, and one of them is to take every opportunity. When I started at Bancroft, it didn't look like the arts class was going to be my connection to NASA or my connection to Sally Ride, but by taking that I was able to get all these other opportunities. So after Bancroft, I went to Hollywood High School, Sheiks. I was a cheerleader over there. I was also, once again, trying to find where I was supposed to be placed in this school that had a very different curriculum set to what I was used to in the UK. One thing that I noted quite early was that here the maths classes are all divided up. There's Algebra 1, Algebra 2, Geometry, Trig, and I had to understand in the UK how far I really got to in maths, because the way we teach maths in the UK is you start with a foundation. Each year they give you another piece of the puzzle. They give you a little bit more, a little bit more. It's not separated into chunks that you kind of have to figure out how to piece together. So once I finally figured that out, I started moving through it. I think when it came to my senior year, I had done pretty much, I finished Calculus BC, AB. I was looking to do AP Calculus BC. There were only 3 students at my school that were looking to take that class. It was a rule in LAUSD, you needed 10 students in order to have the class reinstated. And because we didn't have the numbers, we weren't able to take that class. So I had to pivot. I ended up taking AP Statistics, and I'll talk in a minute about how that affected me later on. In order to continue developing myself there outside of the school, because there were a lot of classes I was sitting in that I'd already learned a lot of the information, more so in my science classes, chemistry, biology, physics. A lot of the information there had been taught earlier on in the UK, especially at my private school education, through experiments and more practical analysis. I decided to take classes at LACC. I think that the benefit that high school students out here have to take additional university classes is something we don't have in the UK, and it should be utilized a lot more by students out here. I ended up taking astronomy, physics, psychology, and ballet. The ballet was thrown in just because I wanted to do something a little different. But that was a really great opportunity for me to see what it's like to actually study at university. How is it different to high school learning? How is it different to what I've learned previously? Particularly the astronomy class, there was a lot of going outside with lasers and identifying different constellations, things that I think in LAUSD they've kind of removed a lot of experiments because of worries, health and safety concerns and things like that, which I think is a real disservice to students because that practical application is so important. And then finally, within the high school as well, I decided to sign up to academic decathlon, so that's that photo along the top there. It's a very, those who don't know, it's just a course where you learn about 10 different subjects within one subject area. So the 2 years that I was a part of it, it was, we were looking at the French Revolution, and we also looked at the Great Depression. So within that, you get to look at economics, social science, art. You do an interview, you give a speech, and so I was able to place for a couple of awards there as well. One last thing which I didn't actually note there down at the bottom here, my mum has always made sure that it wasn't just the school I was learning at. We would visit museums, we would go to additional talks. Down there, she was pushing me to apply for a poetry competition. I also write poetry. I had my little brother help me write this one because I just didn't really want to do it. It was about how we can change the future, and I ended up winning the competition. So that was me at the LA Times. Mayor Vera Ragosa at the time gave us those awards, and I got to bring my whole class at school. So yeah, once again, taking every opportunity that's presented to you. So in 2012, my little sister was born that year, but I also graduated high school, and I decided I wanted to go back to the UK. I kind of missed the environment there. I kind of wanted to see the differences between the education. So I applied for business economics at the time. I went back, I started studying at this university, and unfortunately I didn't find that there was the rigor I was looking for, kind of even less so even than LACC. Because I'd been out of the UK for so long, I didn't really understand, where the unis were to go to. I went to a London university. There were times when the professors had wrote incorrect questions and there were incorrect answers, and my grades were affected by it, and they refused to admit fault. So I decided that maybe that wasn't for me, and it was particularly in the math portion of the course that was really upsetting to me. So I decided at that time to become a chef. It was something I'd always been interested in, and so I used that. I did my chef training and kind of went traveling for a couple of years. As a result of that first university, I did also go to open houses at Cambridge and Oxford. I was really interested in studying there. Unfortunately, this goes back to the high school and not being able to take that Calculus BC course. I could not apply for Cambridge, for maths at Cambridge or physics because they required Calculus BC as an AP. Despite my high SATs, despite my other AP classes I had passed, despite my high GPA, I was not allowed to apply without having that course on the books. So at that point, I did start looking at A-levels. Once again, in the UK, it wasn't divided, so instead of Calculus BC, I would have had to take further maths, which meant relearning all the statistics and Calculus BC and all that other stuff that had been broken up in the US. So after traveling for about 5 years, I did decide it was time to reapply to university. My brother was applying at the same time. He was 7 years younger than me. I just thought it was convenient. He was looking at the US and the UK. We both ended up getting into the University of Kent, which is a really beautiful university. It looks like UCLA type, very green campus, but has quite a good history of physics and astrophysics there, observatory on campus, things of that nature. So I decided to go there. I studied physics with astrophysics. I wanted to kind of get a good base where I could take into any. I was looking at engineering. There were so many options on what kind of engineer you could be. Did you want to be electrical, software, comp sci? And I wasn't sure where to go first. So I thought if I get physics, I got the foundation, I get the formulas, I can apply it wherever I choose to go after that. And then astrophysics to build on that astronomy classes I had been taking at LACC. COVID happened while I was at university. So right before my final year, I started looking around at where the jobs would be in place. Obviously, the environment was changing. There was a lot more push towards data analytics because of everything that was going on globally. And I decided I didn't want to be a data analyst for the rest of my life. So I decided to go and apply to the University of Southampton, which is one of the top 10 schools in the UK, to study engineering. So AIM stands for Advanced Mechanical Engineering Sciences. I wanted to focus on propulsion and engine systems engineering. So that was a chance to look at aircraft, spacecraft, automotive, but also the electrical side. So really just applying all that physics knowledge I had gained. In between there, I also did internships. This photo down at the bottom is an internship I did with an optics group. They're kind of the leaders in Europe for what they do, taking images of the inner eye. I also did an internship with the Institute of Physics, so they accredit my degree. So that was a really good chance to just do some outreach and speak to some of the younger people in my course about how to develop what they were learning in the classroom. Okay, so out of all of that, I then joined Rolls-Royce. My master's degree was for the aircraft was basically taught based off Trent engines. The university was a UTC, which is a university technical college, so basically a lot of the work from the company that they want to do research on, they then send to the university. So I was able to know a lot of people that were already working on Rolls-Royce projects. My master's project I did with Airbus, looking at wire arc additive manufacture, which is like 3D printing with metal. So I was really interested and aligned to this. When I applied for the company, they were also advertising that they were working on nuclear-powered spacecraft, which just sounded like the coolest thing I'd ever heard. And so that's what I wanted to apply for. So when I got there, obviously Rolls-Royce is traditionally quite a white male environment. It's been around for years in the UK, in kind of middle England, so about 3 hours outside of London. So this is where diversity really starts to seep out. One thing they were pushing when I applied was having more female engineers and developing them through the company. So my first placement, I was the only person of color in the entire building that I was based, and that was our production test facility. So that's where we literally assemble the engines that go on large civil aircraft. There were a couple females in the cafeteria area, but that was about it. So I know we talk a lot about imposter syndrome and kind of feeling comfortable where you are. I think through university, through my global travel, also through being a head chef, and having to lead teams of people from all ages, all backgrounds, all cultural differences, it wasn't an issue to me being the only young black female in the room. I learned how to communicate with everybody. So that once again feeds into take every opportunity that is represented to you, even if all you're learning is how to do something that you didn't know how to do, or learning how to be in an environment that you didn't expect to be in. In the company, we describe an engineer as a problem solver a lot of the time. So they also talk about breadth and depth. So it's like you could be a T engineer, so you can have a lot of breadth and know lots of little things about lots of little topics. So you can learn about electrical, you can learn about mechanical, you can learn about process control and business and how we meet our costs, but also to have depth in one area. So with my physics background, with my interest in space, my depth was coming from learning more about the lunar side of things, our nuclear experience, how we can technically improve some of the products. In my day job, so as a graduate, I get to move around different areas of the company. We look at innovation projects and continuous improvement. Someone told me when I was at university, every problem has a solution, you just need to find it. So with the innovation projects, we're looking at problems that have never been given solutions. So one project I'm working on right now is a hydrogen gas turbine engine. So instead of using kerosene to fly, like I did from London to LA, we can maybe use hydrogen. It burns hotter. There are some obviously issues with controlling it that we're trying to figure out how we can do that, but ecologically it will be a better option in the future. And then there's also continuous improvement. So that's maybe problems that we already know the solution to. How do we extend the life of a turbine blade? How do we increase the efficiency of the engine? So what minor adjustments can we make to still make it better? Materials improvements, additional cooling holes, things of that nature. So one area that really surprised me is when I did get to the company, I was imagining there'd be a lot of people on tables with graph paper and calculators and just trying to solve everything, like kind of what you see at university. Or I was thinking it was going to be the complete opposite end, like you see in the movies where there's some guy in the jeans and they got the spanner in the back pocket, and yeah, it wasn't that at all. The engineers there tend to be behind the desk. They try to look at all the problems that they are given and how they can find solutions. A lot of the calculations are usually done through bespoke software. We have software called Phobos that does all our performance data. SCO3 does all our stress analysis. You have to understand the inputs that are going into this, so that's where the foundation from university does begin. But drilling down to exact calculations, unless you're in an analytics team, isn't as necessary. So I think when it comes to my day job, it's more about critical thinking, being able to work in all teams, leadership, personal responsibility, is really what drives the successful engineers I see at my company. And then finally, outreach. So outreach has always been important to me throughout my journey. In high school, I used to volunteer at the AIDS walk. I used to do beach cleanups. While I was at university, I also worked for IOP. I did the campus events. I used to go to schools and do lectures on physics. And within the company, currently I work with the ECP, which is the Early Careers Network. We do conferences such as this where we bring other speakers up and they talk and I hide in the background. And I also did an outreach event called For Primary Engineers where we took very, very young elementary and first grade students and gave them a car that they had to build and meet certain requirements. They also had to do a technical presentation on why they made certain decisions, which was very enjoyable. So those are some photos from the primary engineer event that we held at our Flight Ops Center. So some of the tips, I wanted to kind of share things that I've heard about that I think would just help develop engineers within the US or globally, is first of all building a community in the classroom. So one of the things I talked about when I was in the UK is that I was very competitive with some of the people of color that were in my maths classes. Particularly when we were trying to solve problems or trying to figure out who could figure it out first, who could get to the answer quickest. But then also it provides that additional support, and I didn't quite understand that part. Can you explain it to me? Because I know you solve problems similarly to me. So yeah, building that family so that there's a support, so it's not all on the teachers, and that there's that peer-to-peer mentorship I think is hugely important and definitely helped me through my years. Nurturing all students' potential. So what I mean by this is sometimes there's those students that show that they're really, really passionate about the subject, and there's a tendency to maybe focus on that one person because you know that they are trying to put the energy in. But I believe that there's a way to talk to everybody in the room. I believe that everybody has a reason that they're in there. Maths kind of feeds through everywhere in life. I like to look at life as just a huge equation where you can change the variables and you'll change the output, right? So X, Y, Z, I moved to America, I did this course, it can change your output. So just helping them understand that, even drilling it down to, can you afford that video game? How are you going to save money to buy that big house one day? How much money do you need to earn to live the lifestyle that you've dreamed of? So bringing in those real world examples, not just, an engineer builds rockets and yeah, sure, if that's what the student's interested in, maybe bring some of that in, but the real world examples on how they can navigate life by learning algebra, by understanding geometry, if they want to throw a frisbee or kick a ball, or how does that all play in? And then stay inspired. I know it's a bit of a trite remark, but I think one of the areas that can hurt students the most is having those teachers that come in and are just collecting a paycheck. That you can see that they're tired, they don't want to do it anymore. They have their set workbooks that they don't even change the year on, they don't update, they just kind of give you the same paperwork, which obviously is only going to give a certain response from the classroom. Similarly, a teacher who is passionate, who is inspired, for example, my spacecraft propulsion teacher at university and during my master's course, he brought in startup companies, he brought in people that had worked on the Ariane 6, he brought in people, anyone he met at a conference, if you showed that you were interested in that area, he could give you the contact, or he could give you a piece of information that he had found. And so one of the key inputs, I think, in order to stay inspired is coming to conferences like this, to build that community of people, remind yourself why you became a teacher, why that was so important to you, why you're inspired by the kids. I think it's vital, basically, to building the future engineers. So that was it, that was my spiel.